This is rotational equilibrium problem number 3. I left the pad at school, but I thought maybe somebody wanted to look at it and see what it's talked about. It says a 350 Newton box sits on one end of a seesaw. Man pushes down on the other end with a force of 475 newtons to establish rotational equilibrium. The seesaw is 290 newtons uniform. If the box is 1.5 meters from the pivot, which is not at the geometric theory, then how long is the seesaw? Let's look at this nasty picture. Forgive me, but it is what it is. I knew this seesaw beam right here is going to be L. That's how long we know that is. I call that L just to tell me how long that is going to be. Now, the moment it says uniform, I know I have a force of 200 newtons at the middle. I then can come over here and say, okay, from here, let's change that color so we can see it a little better. From here to the pivot, that 350 is 1.5. Okay, if that's 1.5, I'm gonna call this X right here for the unknown. Okay, with that in mind, I know 1.5 plus X must equal L. This is my 1.5, this is my X, so that plus X must equal L. I use that to solve for X and let X equals L minus 1.5. That's going to come in handy in just a second. Now, we know from the physics that clockwise torques must equal counterclockwise torques. Let's see where these numbers come from. Go back to my drawing for just a second. Let me find it. Don't know what I did with it. Oh, there it is. Notice, I know the 350 is pushing this way, so it's going to cause it counterclockwise. The 200 is pushing this way, going to cause it counterclockwise. I know the 350 is 1.5 away, so that's why I called him 350 1.5. What is this 0.5 L minus X? Well, I know that's going to be, if this whole thing is L, then if I cut this in half right here, then that right there is going to be 1/2 L. If I know this is 1/2 L minus this X right here, that's how much I'm going to have left over at this pivot point right here. So his level arm is going to be 1/2 L minus X. So that's why I stuck that right here. Okay. Now, jump back up here. That should be all my counterclockwise torques. Now let's go look at clockwise. I know my clockwise is going to look like here. How far is it from clockwise? What's this level arm? X. 475 times X should be my clockwise. Now, this right here should be what? Equals. Let's get rid of that. Let's put in the equal sign. That should be equal sign, right? And if you notice, what I did was I did 1.5 plus 0.5 minus X equals 475X. If you recall, we let our X be 1.5, will be L minus 1.5 is my X. I solved for X because they told me to find the length. That's why I let it stay in terms of L. Once you do that substitution, I skipped some math right here. Hopefully, I'm pretty sure you guys can clean this up. Yep, I'm pretty sure you guys, that cleans that side up. Let's see what happens to this side. If it copies that side, now let's see if it will solve for the L again. Yep. So my solution when you solve for L turns out to be that. So L is 2.67 meters. That's how long the bore is. Cool. Or the beam.